In this video we'll show you how we can use the Easy Thread to produce thread milling programs. So I've started Easy Thread from the desktop. I'm running it in full screen mode, but when you start it you may find that it's in smaller mode, so it's up to you how you run it, but I'll run it in full screen mode so that you can see everything that's going on. Okay, so there's various methods of using the Easy Thread product, but perhaps the simplest way is to use the Thread Wizard. Okay, so the Thread Wizard over here tells us the steps, so we'll set up the thread parameters, we'll build our stock file for the simulation, we'll define a tool, it will create the CNC code, and then it will simulate the toolpath. So in this first dialog box here we can set the units to start with, so I'll work in metric, and then we need to set the thread type, the center point, and the toolpath approach. So the clearance plane is the first entry here, which is a distance above Z0 where it's safe to rapid the tool in X and Y. The thread work plane in Z will be the top of the job, so this is normally Z0. The work clearance is a distance above that Z plane where the tool will change from rapid into feed rate. The thread depth is a Z value, so this is the overall length or depth of the thread. The X and Y center point for the thread is here. The thread diameter is the overall outside diameter of the thread. The thread depth is the depth of the thread in the XY plane from the outside diameter to the root base of the tooth. The approach distance here is an XY value, which will mean that in this case the tool will approach 5 millimeters from the outside of the thread, because we're using an external thread. If we were using an internal thread, this would be a smaller diameter than the thread diameter. The approach angle is 45 degrees, so this is how the tool will approach the job. If we were using a tapered thread, we would specify the taper angle here, and we have an entry and an exit cut. Each one, the default is 360 degrees, so the tool will make one complete revolution before it starts cutting the thread, and it will make another 360 cut when it exits the thread. The direction of the thread can either be left-handed or right-handed, and then the cutting parameters for the thread are the number of cuts, so if you need to take 3 cuts of various depths in the X and Y plane, so if we have a thread depth of 2.5 millimeters and I said I wanted 2 cuts, each cut would be 1.25 millimeters deep. The number of chase cuts are secondary cutting, which will not increase or decrease the value of the XY positions, but it will take away any tool deflection that you might encounter. The pitch can either be specified as threads per inch or pitch, and then we have the type of thread, internal or external. If you have multiple XY points, you click this box here and then you'll see a dialog box which will give you the opportunity to specify different locations. And we can also machine Fusee type threads, but that will be covered in a separate video. So that's the first part about setting up the thread type. So we now go to next, and we're going to build our stock model from the dimensions that we give it. We can either build the stock model from an imported VBS file or from an imported STL file. So VBS files are Visual Basic scripts, STL files are triangulated solid models, but for our case we'll just build the stock model from the dimensions we're about to give it. So we click on next, and the dimensions are the outside diameter of the bar, the length of the bar, and the Z work plane, in this case Z0. If we wanted to see a taper, then we would put the taper angle in here. If we were using an internal thread, then obviously we'd need to specify a bore and the length of that bore. The resolution in degrees is just a factor for creating the STL file, and these entries here are just where the STL file will be stored. So if we click build STL from the dimensions, then we'll have a diagram here which shows us the dimensions of that part. So this is looking in the ZX plane, so this is Z0 here, and this is half of the bar. So now we can click next, and we'll either build the tool from the dimensions we're about to give it, or we can build the tool from an imported Visual Basic file. The Visual Basic file is a file that can be exported from the PartMaster CAD system. If you have a complex tool, then you can draw it up or get it from a tool catalog and create a Visual Basic script which we can just import. So we'll just build it from the dimensions I'm about to give it. So the station is the tool number in your carousel. If you've got a manual machine, then it doesn't really matter. The tool length is the overall length of the tool. As you can see here on the right hand side, that's the overall tool length. The flute length is from the base of the tool up to the cutting size here. The tool diameter is the outside diameter of the tool, and the flute diameter is the diameter of the flute. If we were using tapered cutters, then we would enter the taper angle here, but for most instances then that will be 0. The chordal tolerance, you can leave that as the default. The number of teeth that the tool has, in this case we'll use a single tool. The included angle of the tool, this will depend very much on the type of thread it is you're machining. And the tip radius will be, this is the tip profile here, so it's the radius at the end there. So it can either be a radius tipped, it can be a flat tip, or it can be a pointed tip. So when you enter the dimensions in here, then we click on build the tool image, and it puts the data into these 3 windows there. For instance, if I change the tip radius and said build tool image, we can see that it's updated that tool image there. Okay, so we click next, and it's creating a file for us, and the default extension is a .tap, but we can change all of these defaults as we want to. So as a default, the file will be stored in the My Documents, Dolphin CADCAM, Easy Tools, Easy Thread folder, so give it the name of the file that you're creating. So this is the G-code file we're creating now. Okay, so that goes away and creates a G-code file, which it has done, and it then calls up the simulator. So this is the machine tool simulator here, and when it's imported all the cutting data, okay, then we can see the stock that's been built, which is just the a cylinder. We can see the tool that's been created from the dimensions we've given it, and then on the right hand side here, if we click on the cut sim tab, then we can set the accuracy of the model. Don't set it too high, because it will give you a very accurate model, probably use up huge amounts of memory and take a long time to view. So if you dial it down so it's sort of between low and medium, and then reset the graphics, and then we've got simple video controls across the top here. So if we run that part, you can use the mouse wheel to zoom in, you can use the right hand mouse button to pan, and the left hand mouse button to rotate. So as we can see here, it's taken one cut at full 360 degrees before it starts to machine the helix angle for the thread. This is taking a single cut. If I had said I want multiple cuts, then we'd see this taking multiple cuts in the XY plane. And when it gets to the top, it'll put in another 360 degree exit cut so that we're sure that we've got a nice clean start to the thread. Okay, so that's the thread cut there. So when we close down the simulator, we're taken back to the Easy Thread dialog box, and we can save the part, recall the part, or start a new part. If we make any changes to any of the parameters, then the CNC code and the simulation will be run automatically, because this checkbox here is checked. Okay, so that's how we use the thread wizards for cutting parallel threads in the Easy Thread.